Hello students, the transition elements chapter, one important question is discussed now. Question is, why the chromium 2 plus is reducing and Mn 3 plus is oxidizing when both have a D4 configuration? Both ions are a D4 configurations. Okay, check it now. Okay, here the chromium outermost electronic configuration is 3d5 4s1 and manganese outermost electronic configuration is 3d5 4s2. Now in the chromium 2 plus ions, remove the 2 electron from the original configurations. So you get the 3d4 only. And also the Mn3 plus 3 electron is removed from the original configuration. So you get the 3d4. Okay. Now the both ions are the same configuration. Okay. So one is a reducing and another one is a oxidizing. Why? That is a question. So chromium 2 plus. Okay. Now you deal the two aspects. One is a stability electronic configurations. Okay. So chromium 2 plus is a reducing means. Chromium 2 plus is a reducing means it gets oxidized. Oxidized means it loses one electron. Okay. So the chromium 2 plus lose one electron, then it is changed into chromium 3 plus. Chromium 3 plus. Okay. The chromium 2 plus ions configuration is a the D4 configurations. Chromium 2 plus is a D4 configuration. So chromium 3 plus is a D3 configuration. Okay. The D3 configuration is a highly stable because, okay, and the 5 orbital and the d orbitals can be in the crystal field splitting energy can be split into, okay, the 5 orbital of the d orbital, it's going to crystal field splitting energy, it can be split into T2G and Eg. And Eg. Eg have a 2 orbital and T2G is a 3 orbital. Okay, it can be split into 3 orbitals of a T2G and 2 orbitals of a Eg. Already the D3 means the 3 electrons present in the d orbital. Okay, that 3 orbitals is present in the T2G level of a lower level. So T2G is a killer clear, it is a lower level. Eg is a upper, that is a higher level. Okay, so in this state it is a more stable state. Okay, in this state it is a very stable. Okay, okay. Next, that Cr3 plus is a, it's changed into Cr 2 plus is changed into Cr3 plus. In this it's a very stable coming up to the Mn3 plus. Okay, this is also D4 configurations, but Mn3 plus is a strongly oxidizing agent. But the oxidizing agent mean Mn3 plus get reduced. So reduced mean it gain one electron. So Mn3 plus gain one electron, it changed into Mn2 plus. So here the prefer Mn2 plus configurations. Why? Because the Mn2 plus has a more stable configuration. So the Mn3 plus is a D4 configuration and Mn2 plus is a D5 configuration. Okay. We all know the D5 configuration is a half-filled configuration. D5 is a half-filled configuration, so it is a more stable. Half-filled, it is a half-filled, so it is a more stable configuration. So Cr2 plus is reducing when the Mn3 plus is oxidizing. Okay, so just because they will attain the stability. So after the chromium 2 plus gets oxidized and chromium 2 plus gets oxidized and Mn3 plus gets reduced. In the second aspect, the E0 value for the couple Cr2 plus changed into Cr3 plus, that value is a minus 0.41 volt. Whereas the E0 value for the couple Mn3 plus and Mn2 plus, which is equal to plus 1.51. Its value is a plus 1.51 volt. Plus 1.51 volt. Okay, this high E0 value, therefore the low oxidation state is preferred. Here the E0 value is a high A, so it is a low oxidation state is preferred. Here, which one is the lower oxidation state? Mn2 plus is the oxidation state. And chromium is a negative value, it means a higher oxidizing stable is preferred. So here the chromium 3 plus is a higher oxidizing state. Okay, so chromium 3 plus is a higher oxidizing state, so it is a prefer here. Okay, this question is that is the answer for this question. I hope you are very understand this question. Thank you.